Hello, everyone. My name is Kavita. And today I'm going to be talking to you about how to leverage online opinions to support decision making. So agenda for today, first I'll introduce the problem. Then I'll give you a demo of Find I Like, which is a system that tries to leverage user reviews to support decision making. Then we'll move into the technical components of Find I Like. First we'll touch on the search component. Then I'll move into the summarization component. So let's get right into it. So what people think and say heavily influences our day-to-day decision making. So how many of you have been influenced by family and friends on what companies to work for, or what cool places to visit, or even what kind of tools to use for specific data science work? So before the web became popular, life was really simple. Our influencing sources were either family and friends, or maybe consumer reports. But now, life is a mess. If we want opinions, we can tap into all these different sources, right from e-commerce sites, online directories, blogs, reviews, social networking sites, and a whole lot more. But even though we have all of this information available at our disposal, we actually don't have the tools to leverage this information efficiently to support decision making. So let's take a very classic example of looking for a hotel in a completely unknown city. So you typically would have a few requirements. So let's say your first requirement is safety, because you don't want bullets flying right over your head. And if you're like me, you might be claustrophobic, so you might want rooms that are spacious. And you might be really picky about your beds, so you might want hotels that just offer Tempur-Pedic beds. So think about this for a second. Is there a way currently to directly and easily find hotels matching your personal preferences? Maybe by reading 2,000 reviews and finding one review that talks about one of your preferences. So the information that you're looking for is there. It's somewhere in the reviews. But you just have to read all the reviews and perform your own mental data mining. So you can see that this process is not really efficient at all. So with that, I'm going to present a demo of Find I Like, which is a preference-based hotel search engine. So this was actually developed as a research prototype with my advisor a few years ago. And the goal here was to showcase different algorithms that try to leverage user reviews to support decision making. So let's look at the demo. Okay. So let's say you're looking for a hotel in Los Angeles, California, and your number one preference is safety, and you want spacious rooms, and you want Tempur-Pedic beds. So you can specify all of this using natural language keywords. So what the system tries to give you back are hotels matching your personal preferences in the user reviews. So you also get to see why the preferences were matched, just snippets of reviews, and how well each preference was matched in relation to all other hotels in the same city. So like for Tempur-Pedic, somebody said they really liked the Tempur-Pedic beds. Somebody else said the Tempur-Pedic beds were very comfortable. So if you want to see more reviews about Tempur-Pedic beds, you just get right into it, and then you can read all the reviews. So this is a way for you to validate and try to get more context. So same thing for spacious rooms. You get to see snippets of reviews that talk about spacious rooms. And then if you want more information, then you can go right in and read more reviews about spacious rooms. And once you have a set of hotels that you're really interested in, you can actually go in and read the summaries of reviews. So this is an aggregation of what people think in general. So if something piques your interest, you can go in and read all the reviews. But you don't really have to, because it's already summarized for you. And it also tells you how many people had a similar opinion. So it provides some kind of analytics. Now this is a different view. This is a summary of common keywords within the reviews. So if something like front desk piques your interest, you click on it and you see only the sentence that talks about front desk. And then if you want more information, then you can expand and read the full review. So it's different summarized views. So same thing for valet parking. If it piques your interest, click on it and you get only the sentences. And then if you want more information, then you can read the full reviews. OK, so end of demo. I'm moving in back to the slides. So all these different views that you saw are actually different tools to help you make decisions more efficiently. And what I showed you was in the context of hotels. But you can imagine you can apply the same concept in a lot of other domains. So for example, in product search. So let's say you're looking for a T-shirt. You want something that's baggy, has a V-neck, and doesn't shrink. So this type of information is usually there in the reviews. A completely different example is healthcare provider search. So let's say you're looking for a family doctor, and you want someone who speaks fluent Spanish, is good with kids, and has a calming clinic. So this type of information is also there in the reviews. So now the question becomes, how can you implement such a system? So in the Find I Like demo that you saw, there were actually several different components. The first is a preference-based search component. So how do you match the user's unstructured preferences with the user reviews to recommend the most appropriate entities, the hotels? So that's the first component. The second is understanding the user's query. So if the user's looking for a hotel that's good for kids, does this also mean child-friendly? Or if the user's looking for a baggy T-shirt, does this also mean oversized? So understanding the user's query. Now the third component is providing a concise view of the reviews so that the users don't have to read every single thing. They can just glance through and get a gist of what's going on. And fourth component is combining your unstructured information with structured information. So in this example, we are combining structured preferences with distance information, which is more structured. So now let's zoom in to the search components. So in traditional search, what you do is you enter a query, and you get back a bunch of documents that are relevant to your query. But in preference-based search, your query is essentially a set of preferences. And what you get back are entities. And entities can be hotels, doctors, anything at all. And each entity here is represented by what I call an entity document. And in this entity document is where you have all your unstructured text. So you can have one field for all your reviews. You can have another field for question and answers, and another field for all the description. So in this example, the entities are hotels, and the entity document contains a concatenation of user reviews. So then what you do is, once you've created these entity documents, you would then index the entity documents using your regular search technology, like Lucene-based technologies. So the idea here is that the more your preference, your query, matches the keywords in the entity document, the higher the rank of the corresponding entity. So that's the general thinking here. But there are some technical considerations that you need to think about when trying to implement a system like this. So first is, what if you have uneven entity document lengths? So what does that mean? So which means, let's say Hotel A has 1,000 reviews, but Hotel B has only 10 reviews. So in this case, the entity document of Hotel A is going to be much longer than that of Hotel B. So what can happen is that Hotel A may unfairly rank higher than Hotel B simply because of more keyword matches. But this doesn't mean Hotel B is not good. So how do you level up the playing field so that both hotels have a fair chance of ranking highly? So one thing you can do is use a scoring model that has a built-in saturation point. So which means the keyword matches only counts up to a certain point, and after which it just plateaus. So with this, all entities get a fair chance of competing fairly against each other. So that's the first thing you need to think about, the entity document length. Now the second thing is, how do you match similar concepts? So let's say you're looking for a pet-friendly hotel. And pet-friendly should match pet-friendly as is. It should match dog-friendly. It should match pets are welcome and animal-friendly. But in a simplistic model, pet-friendly will only match pet-friendly. So what do you do about this? So one way to address this is to expand your query with related concepts. And these related concepts can either be manually defined, or you can use all the data that you use to create your entity document and train a word or phrase embedding, and that will give you pretty nice similar concepts. So that's one way to address the issue of similar concepts. The third thing that you need to think about is, how do you deal with negations? So let's say, again, you're looking for a pet-friendly hotel, but the review says this hotel was not pet-friendly. So in a simplistic model, this will actually count as a match. But we know that this should not count as a match. So how do you address this? So one way is to look at surrounding negations. So all matches with surrounding negations should not count towards relevance. So this is an easy fix for negations. But it may not work in all cases where you have sarcasm and all sorts of things. Yeah. So these are 3 different things to think about when implementing a preference-based search engine. There will be a lot more when you implement a system like this. For more information about how a preference-based search engine works, I'll refer you to my paper on opinion-based entity ranking. It has a lot more details around it. So now let's switch gears and move into the summarization component. So what is it that review summaries or opinion summaries can provide that general search or preference-based search cannot? So I would argue it's unexpected information that can make or break the deal. So here's an example. So this is a keyword summary from the hotel that matches all my preferences on safety, Tempur-Pedic beds, and spacious rooms. But if you look at valet parking here, somebody said it's $26 and it's way too expensive. And somebody else pours oil in the fire saying that this is way too expensive for a valet parking rate. So this can become a deal breaker. So I would have never have known this unless I had come to this page and seen that valet parking was an important point of discussion. And then as I dig further, I realized that it's just way too expensive. So if I didn't have this tool, I would have just gone to the hotel and paid through my nose. So you can see how unexpected information can really affect your decisions. So in terms of generating summaries, you actually have lots of different options. You can generate natural language summaries, you can generate keyword summaries, or something even completely very structured, like cleanliness 5 stars, comfort 2 stars. So lots of different options here. But let's talk about the harder one, natural language opinion summary. So this is an aggregation. This is from the Find I Like system. So it's an aggregation of what people think in general. And what's nice about this, it's concise, it feels natural, and it immediately conveys essential information. And it also provides some form of analytics by telling you how many people had a similar opinion. But it's not really trivial to generate a summary like this. So in the Find I Like system, we developed an algorithm called Opinosis, which is a graph-based sentence compression approach. Sounds a bit scary, but what it means is that you can actually leverage the redundancies, structural redundancies in sentences to extract out new sentences or new phrases that are true grammatical, but can become a summary. So in this example, you can leverage the structure redundancies and extract out bed was comfortable. So that's still grammatical. And it does summarize these 3 sentences. So that's the general idea. But in the Opinosis algorithm, we used a word graph data structure to efficiently do this. So the word graph will efficiently find the structural overlaps. So here, bed was comfortable will immediately pop out as a very salient path. So what's nice about this technique is that it's really speedy for ad hoc summarization. So you don't have to pre-compute the summaries. You can generate it as needed. And this also means that you can generate summaries for topics that are very specific, selected by users. And another nice thing is that it captures redundancies naturally. So you immediately know how many people had a similar thought. So you don't have to implement a separate counting component. It's already built in. And the third thing is that you're basically using your existing text to generate summaries. So you are keeping things very simple. And this makes it really efficient. So if you want to try out the Opinosis algorithm, you have 2 options. You can try out the web API, or there is a downloadable jar file that you can run locally. Yeah. And so in summary, your unstructured data is not going anywhere anytime soon. It's just going to continue to grow. And a big chunk of this is actually text data. And if you can leverage this text data in very creative ways to provide a much better search and decision-making experience, then your users are going to make decisions much faster. And as a result, they are more likely to do business with you and keep on doing business with you because you help them make so much better decisions than they would have otherwise. Thank you.
I have a quick question. How can you trade with user spam, user reviews? Like anyone can go and try all the stuff that's actually true?
Yeah, so that'll have to have a separate component where you detect spam before you even use the reviews. So you'll have to have a spam detection algorithm prior to using the reviews. Yeah. What's your second question?
No, that's it.
OK. Yeah. Okay.
Do you do any kind of length normalization for really bland reviews? Like it was good or it was bad. Do you even bother with those reviews, or do you keep everything?
You can pre-process it right before using, like length normalization. You can do all of that before indexing.
Did you do that, or did you find it helpful?
I didn't do that, and I don't know if it's helpful or not. Yeah.
My question is just related to that. When you have the slide that said you have a short review where we don't have much information about it, but it might be something to tell. You got lots of people go to, you have more information, and you said that you use TF flattening that curve. So VM25 will do that naturally.
Mm-hmm. Yeah, it does.
But the other factor, though, that Lucene built in is document normalization.
Mm-hmm.
You see something long, and it'll take the length of the text as a factor to dampen the relevancy of something. So I wonder if you tuned the norm or found the norm to be ineffective in your case. You know. I don't know if you did or not.
Yeah, I don't remember. I have to refer back to my paper on opinion-based sanity ranking. Yeah. But we did change the denominator for BM25, yeah, to use something slightly different. Yeah.
So you did mention about the negative comments, right?
Mm-hmm.
So did you try to do any sentiment analysis and try to segregate the phrases by that?
Not explicitly, like not before the process. Are you asking about like before indexing or?
Yeah, while generating those phrases, did you try to distinguish them by sentiment, or did you just?
No, we just indexed everything.
Reject the negative ones?
Yeah.
Did you take ratings also in consideration?
So this assumption was that you don't have the ratings available. Yeah.
you take only positive reviews and comments, or you consider both negative and positives and either boost or deboost product?
Yeah, it takes everything into consideration. Then you can boost or deboost as needed based on the query. Yeah.
So this is the hotel industry, which has a really low velocity of inventory turn, but an industry like e-commerce has a much higher velocity of inventory turn, which means a lot of new items with no reviews. So
Yeah.
thought about how to deal with that.
Yeah, so in those cases, you can actually use the description. So the description usually has lots of information about the product itself. So as you build volume on the reviews, just use the description and the question and answer, or any other external information you can get from the catalog.
A number of the questions so far have sort of focused in one way or another on the issue of the quality of the reviews. I was wondering, and I know that personally when I evaluate reviews, there could be a review that says something that I'll just totally discount because my own subjective qualitative analysis of that particular review suggests that the person who wrote it, I might not value the same things that they do. I'm wondering if you thought about an attempt to do some sort of qualitative analysis of the reviews to affect the ranking.
Yeah, in the find-alike system, we did not, but we do know that some can be spammy reviews, some can be valid reviews, and so we concluded that we need to have a separate component to actually evaluate the quality of reviews and take that into consideration when ranking the entities. Yeah, so give a score to each review, basically.
Yeah, I realize that that's a sort of fraught topic, maybe.
Yeah.
Realistically, like that is how I personally evaluate reviews.
Yeah.
It's much more important than like the, more quantitative approach.
Yeah, and also the number of votes for the review can be used in boosting. Yeah.
That's true.
Yeah.
Although even that, I think, as a quantitative approach, I think leaves something to be desired in terms of like evaluating the quality.
Mm-hmm. Yeah. Good point.
I'm curious about your thoughts about sparsity. So, in particular, that there seems to be a risk as you add preferences that you end up favoring the places where you have more reviews. And there seems to be a difference between saying, I'm sure this meets the preference, I'm sure this doesn't meet the preference, and I don't know. And eventually, right, you want the don't knows to be more available. As you get more specific, there's this risk that all you're going to end up doing is getting the most heavily reviewed content, probably as an unintended bias.
Yeah, so it depends on the scoring formula that you use under the hood as well. So if you favor more matches, then all the highly reviewed ones get higher rank. But if you have a way to plateau the keyword matches out, then it's I think that each entity gets a fair chance.
I guess maybe a simple example would be, let's say that people say they're cheap or expensive, right? So if you know it's cheap, you know it's not expensive, and vice versa. But the don't know should be, I would imagine, more useful. So I don't know if there's a notion there of negative information relative to your preference versus uncertainty.
Yeah. So I'm not sure I understand your question, but I'll talk to you after the session. Yeah.
You said that you have tweaked the PM25 algorithm. So instead of that, did you even try using the boosting function, boosting query, instead of tweaking the PM25?
Boosting. I think we did try boosting. Yeah.
So was there any issue with boosting query or boosting function?
I don't recall, but let me check that up. I don't recall. Yeah. One more question? Yeah.
Yeah, I saw from the summaries you had, like this place was bad, etc. I was wondering, was there actually any sentiment analysis in that, or was it just me that was bad together?
Could you repeat that, please?
Sorry?
Could you repeat that question? Yeah.
I noticed on the summaries you had saying like this place is bad.
Yeah.
It was cheap, but say the bad, was that purely a summary based on the keyword bad, or was it actually some sentiment analysis in
So we did normalize some of the words, like bad could also mean horrible. Yeah, yeah. And now you can use the word embeddings to further normalize things. Yeah. Any more questions? Thank you.